So actually it is very easy to see that the right angle PQC is similar to the right small triangle NMC according to angle similarity rule. That is to say, this is angle, this angle equals to 30 degrees. It is a common angle that belongs to both triangles. It belongs to the big triangle QPC, and angle. This angle also belongs to the small triangle NMC. So this is angle C, that is a common angle that belongs to both triangles. In addition, those two angles are both equal to 60 degrees and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees and therefore they are equal to each other. So if we found out that the right triangle PQC is similar, this is the sign of similar, to the right triangle NMC according to angle similarity rule. And from the fact that those two right angles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side MN of the right small triangle NMC over side QC of the big right triangle PQC is equal to side PQ, side PQ of the right triangle PQC or side NM of the small right triangle NMC. Actually, it is equals to side NC of the right triangle NMC over side PC of the right triangle PQC. If we derive that for the fact that those two right triangles are similar to each other, that MN over QC equals to NC over PC. MN is A over QC. QC is A plus A, that is 2A, and it is equals to NC. NC is the missing side, so leave it as it is, over PC. PC equals to 4 units in its length according to what is given as the question. So if we found out that A over 2A equals to NC over 4. Repeat again. We found out that A over 2A equals to NC over 4. Here we have A in the numerator and A in the denominator, so A will get cancelled. So in this side of the equation we left only with one half. It's equals to NC over 4. Here we cross multiply this equation and we get that 4 equals to 2NC. Here we divide this equation by 2 and finally get that NC equals to 4 over 2, that is 2. So we found out that the missing line segment NC equals to 2 units in its length. NC equals to 2 units in its length. Pn equals to PC minus NC. Again, Pn equals to PC minus NC. So we write it down. Pn equals to PC minus NC. So Pn in total equals to PC that is 4 minus NC that is 2. 4 minus 2 is 2. So Pn equals to 2 units in its length. In the next step, I'll copy the big triangle A and B. In the new page, we'll analyze this big triangle A and B. This is angle A and C, that is equals to 60 degrees in size. This is angle ABC, that is also equals to 60 degrees in size. Side AB equals to 5 units in its length, according to what is given in the question. So here, this is triangle A and B that are copied from the original drawing. This triangle A and B, 60 degrees plus 60 degrees, it is 120 degrees, and therefore this missing angle must be equal to 60 degrees in its size. Well, because 180 degrees plus 60 degrees, it is equals 120 degrees plus 60 degrees, it is equal to 180 degrees, that is the sum of the areas in any triangle. So if we found out that triangle A and B is an equilateral triangle. Triangle A and B is an equilateral triangle. That is to say, all of its sides are equal to each other. So AB equals to 5, and B also equals to 5, and AN equals to 5. Okay, so NB equals to 5, and here we have what is the length of side CB. CB equals to NB minus NC. Again, CB equals to NB minus NC. So it is now side CB equals to NB minus NC. So CB equals to NB, that is 5, minus NC, that is 2. So in total, CB equals to 5 minus 2, that is 3. So CB equals to 3 units in its length. In the next step, from the vertex A, we will draw perpendicular on CB. Again, from the vertex A, we will draw perpendicular on CB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A in CB. This point is point O. We define the length of AO as H. It is actually the height to the base CB, because it creates 90 degrees with the base CB. So we know that the area of any triangle equals to the base of the triangle times the height to the base over 2. So I copy the right triangle A or B in the new page, and we'll find out the length of side AO of the right triangle AOB. Angle ABC equals to 60 degrees in its size. So actually, this is right triangle AOB that are going from the original domain. This triangle AOB, sinus 60 degrees equals to H over AB. Again, sinus 60 degrees equals to AO over OB. AO over OB. Sinus 60 degrees equals to AO. AO is H over OB. OB is 5. So in total we found out that sinus 60 degrees equals to H over 5. Sinus 60 degrees is equal to 3 over 2. So we substitute sinus 60 degrees by square root of 3 over 2. So square root of 3 over 2 equals to H over 5. Here we will multiply this equation by 5 and finding that H equals to 5 times square root of 3 over 2. So if we found out that the height H equals to 5 times square root of 3 over 2. Our task is to find out the area of this triangle ABC. The area of triangle ABC is equal to the base of the triangle that is CB times the height to the base that is AO over 2. Repeat again. The area of the green triangle ABC equals to the base CB times the height to the base that is AO over 2. So the area of the green triangle ABC is equal to the base CB. CB is 3 times the height AO H over 2. And again, if you found out the area of this green triangle ABC, it is equal to the base CB that is 3 times the height AO that is H over 2. But we already found out that H equals to 5 times square root of 3 over 2. So we substitute H by 5 times square root of 3 over 2. And we find out the area of triangle ABC. The green triangle ABC, it is equal to the base that is 3 times the height H that is 5 times square root of 3 over 2 divided by 2. So in total we found out that we're looking for this question, that is the area of the green triangle ABC is equal to, in the numerator we have 3 times 15. So in total that is 3 times 5, that is 15. So in total in the numerator we have 15 times square root of 3 divided by 2 times 2, that is 4. So in total we found out that the area of this green triangle ABC is equal to either 15 times square root of 3 over 4 square units in its size, or in terms of numbers, the value of this expression is 6.5 square units. And again, we found out that the area that we're looking for in this question, that is the area of this green triangle ABC, it is equal to either 15 times square root of 3 over 4 square units in its size. In terms of numbers, the area of this green triangle ABC is equal to 6.5 square units in its size. So we finish with the first question. In the next step, I present to you the second question, and we will solve the second question of this lecture. In the second question, our task is to find out the length of this line segment AP that is equal to x. We have to find out the value of x. So in the domain we have a semicircle. Point O is the center of the semicircle. Line segment PO equals to 10 units in its length. Line segment QP equals to 21 units in its length. This is line segment QS that is equals to 16 units in its length. This is angle PQS that is equal to 90 degrees in its size, Again, our task is to find out the length of this line segment AP that is equal to x. We have to find out the value of x. So first of all, we will complete the semicircle to a circle. So completed the semicircle to a circle, and we will extend the segment QP by a straight line until it touches the circle. And we define the touching point of the extended segment QP with this circle. This point is point M. We join points M and S together by a straight line. By joining points M and S, we created here peripheral SQM. This is peripheral SQM. This is peripheral SQM. Peripheral SQM is equal to 90 degrees in size. And according to rule 5, any peripheral that is equal to 90 degrees in size must subtend on the diameter of the circle. So I think rule 5. According to rule 5, any peripheral angle that is equal to 90 degrees in size must subtend on the diameter of the circle. In that moment, we have a circle, and we know that MN is the diameter of this circle. Peripheral angle MAN is equal to 90 degrees in size, therefore it must subtend on the diameter of the circle. And indeed, peripheral angle MAN subtend on MN, that is the diameter of this circle. So according to this rule 5, any peripheral angle that is equal to 90 degrees in size must subtend on the diameter of the circle. So we have here peripheral angle SQM that is equal to 90 degrees in size, and therefore it must subtend on the diameter of the circle. Peripheral angle SQM subtend on SM, and therefore SM must be the diameter of the circle according to rule 5. So it is done. We should find out that SM is the diameter of the semicircle according to rule 5. Point O is the center of the circle. Point S is the point of the circle itself, therefore OS is the radius of the circle. We define the radius of the circle as R, so OS equals to R. Likewise, point O is the center of the circle, point M is the point of the circle itself, therefore OM is also the radius of the circle, that is equals to R according to our definition. In the next step, we will do a construction, that is to say from this point, point O, that is the center of the circle, we will go perpendicular on QP. Again from point O, we will go perpendicular on QP. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and QP. This point is point M. We have, this is angle M. That is a common angle that belongs to both triangles. Angle M belongs to the right triangle MON, and angle M also belongs to the big right triangle, triangle QSM. So we define the common angle M as alpha. So the right big triangle MQS, this angle equals to alpha, this angle equals to 90 degrees, and therefore this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees it is equal to 180 degrees, that is the sum of the angles in any triangle. Likewise, in the small right triangle NOM, this angle equals to alpha, this angle equals to 90 degrees, and therefore this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees, that is the sum of the angles in any triangle. So actually it is very easy to see that the big right triangle QSM is similar to the small right triangle, triangle NOM, according to angle similarity rule. That is to say, in both triangles we have this angle that is a right angle, therefore those two angles are both equal to 90 degrees, and therefore they are equal to each other. In addition, this is the common angle M that belongs to both triangles, so we can write down that angle M equals to itself as a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. So actually prove that all the angles of the big right triangle QSM are corresponding equal to all the angles of the small right triangle, triangle NOM, and therefore those two right triangles are similar to each other according to angle similarity rule. So it is known, if we found out that the big right triangle QSM is similar, this is the sign of similar, to the small right triangle, triangle NOM, according to angle similarity rule. And for the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side NO of the small right triangle NOM over side QS of the big right triangle QSM is equal to side OM of the small right triangle OMN over side MS of the big right triangle QSM. Again, from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side ON of the small right triangle OMN or side SQ of the big right triangle QSM is equal to side OM of the small right triangle OMN or side SM of the big right triangle QSM. ON is the missing side, so leave it as it is, over QS. QS equals to 16 units in itself according to what is given in the question, and it is equals to OM. OM is arc, is the radius of the circle, over SM. SM is the diameter of the circle, that is equals to 2R. So in total, if we found out that NO over 16 equals to r over 2r. We have r in the numerator and r in the denominator, so r get cancelled. So in this side of the equation, we have to only with 1 half is equals to NO over 16. Here we multiply the equation by 16. So we get that NO equals to 16 over 2, that is 8. So NO equals to 8 units in its length. This is side NO, that is equals to 8 units in its length. In the next step, I'll copy the right small triangle NPO, and in the page that we find out the missing side PN in this right small triangle NPO. Actually, this is the small right triangle NPO that according to the original drawing, according to the Pythagoras theorem, in this small triangle NPO, PO squared, that is the square of the hypotenuse, is equal to NO squared plus NP squared. Which again, according to the Pythagoras theorem, in this right triangle NPO, PO squared, that is the square of the hypotenuse, equals to NO squared plus NP squared. PO is 10, therefore PO squared is 10 squared, that is 100. And it is equals to NO squared. NO is 8, therefore NO squared is 8 squared, that is 64, plus NP squared. So in total we found out that 100 equals to 64 plus NP squared. Here we subtract 64 from this equation, and we get that NP squared equals to 100 minus 64 is 36. So here we take a root out of this equation, we get that NP equals to the square root of 36, that is 6. So if we found out that the missing side NP is equal to 6 units in its length. This is the missing side NP, that is equal to 6 units in its length. What is the length of line segment NQ? NQ equals to QP minus NP. Again, NQN equals to QP minus NP. So write it down. QN equals to QP minus NP. So Q1 equals to QP, that is 21 according to what is given as the question. QP is 21 minus NP. We just right now found out that NP equals to 6. So in total 21, Q1 equals to 21 minus 6, that is 15. So if we found out that Q1 equals to 15 units in its length. This is line segment Q1 that is equals to 15 units in its length. In the next step, we join points O and Q together by straight line. By joining points Q and O, we get that the right triangle Q and O. So I'll copy triangle Q and O in a new equation. We will implement the Pythagoras theorem on this right triangle Q and O. N O equals to 8 units in its length, Qn equals to 15 units in its length, and the hypotenuse, that is also the radius of the circle, it is the missing side. Again, the hypotenuse QO is the missing side, it is also the radius of the circle. So actually, this is the right triangle Q and O that comes from the original drawing. If by PT a relation for Pythagoras theorem, this right triangle Q and O according to the Pythagoras theorem, QO squared, that is the square of the hypotenuse, is equal to NO squared plus Qn squared. And again, according to the Pythagoras theorem, in this right triangle Q and O, QO squared, that is the square of the hypotenuse, equals to ON squared plus QN squared. So QN is the missing side, QO is the missing side, so we leave it as it is. QO squared equals to ON squared. ON is 15, therefore ON squared is 15 squared, that is 225 plus QN squared. Actually, QN is 15, therefore Qn squared is 15 squared, that is 225 plus ON squared. ON is 8, therefore ON squared is 8 squared, that is 64. So in total we found out that QO squared equals to 225 plus 64. 225 plus 64 is 289. So in total we found out that QO squared is equal to 289. Here we take a root out of this equation and finally get that QO equals to the square root of 289, that is 17. So if we found out that the length of the hypotenuse QO is 17, QO is also the radius of the circle. So QO, so the radius of the circle is equal to 17 units in its length. The radius of the circle is also AO. So AO equals to AP plus PO. So AO equals to AP, that is X, plus PO, that is 10. So in total, AO, that is the radius of the circle, equals to X plus 10. The radius AO equals to 17. So we substitute AO by 17, and you get that 17 equals to X plus 10. Here we subtract 10 from this equation, and finally get that X, that is the line segment that we are looking for in this equation, it is equals to 17 minus 10, that is 7. So X equals to 17 units in its length. AP is equals to X is equals to 7 units in its length. Repeat again, which we found out that the length of this line segment AP that equals to X is equal to 7 units in its length. So finish with the second question. In the next step, I'll summarize the lecture. Let's start with the first question, of course. in the first question, our test was to find out the area of this main triangle, triangle ABC. So in the drawing we have the big quadrilateral QABCP. We know that AQ equals to QC. We also know that this is angle PQC, that is the right angle. We know that AB equals to 5 units in its length, PC equals to 4 units in its length. And again, our task is to find out the area of this main triangle, triangle ABC. So first of all, from point A, we do perpendicular on QC. Again, from point A, we do perpendicular on QC. Triangle AQC is an associated triangle because AQ equals to AC, and QC is the base of the associated triangle, triangle AQC. Okay, so we have the rule that says that the perpendicular to the base of an associated triangle bisect the base. Again, we have the rule that says that the perpendicular to the base of an associated triangle bisect the base. So according to the rule that I mentioned, the perpendicular AM to the base QC of the associated triangle, triangle AQC bisects base QC. That is to say, the base, it divides the base QC into two halves. The first half is QM and the second half is MC. And of course, they are equal to each other. So if we define the first half QM as A, then the second half MC must be also equal to A because they are equal to each other, according to the rule that I mentioned. In the next step, we extended the perpendicular AM by a straight line until it touches side PC. And we define the touching point of the extended perpendicular AM with side PC. This point is point N. In triangle QCP, this triangle QCP, 90 degrees plus 60 degrees, it is 150 degrees, and therefore this third angle must be equal to 30 degrees in size. According to the rule that says that the sum of the angles in any triangle is equal to 180 degrees. In the small right triangle MNC, 30 degrees plus 90 degrees, it is 120 degrees. And therefore this third angle must be equal to 60 degrees in its size, according to the sum rule that said that the sum of the angles in any triangle is equal to 180 degrees. It is very easy to see that the big right triangle QPC is similar to the small right triangle MNC according to angle similarity rule. First of all, this is angle C, that is a common angle that belongs to both triangles. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to 60 degrees and therefore they are equal to each other. So if we found out that all the triangles of the big right triangle QPC are correspondingly equal to all the triangles of the small right triangle, triangle MNC. And therefore those two right triangles are similar to each other according to angle similarity rule. So in the again, we found out that the big right triangle PQC is similar to the small right triangle, triangle NMC according to angle similarity rule. And for the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side MN of the small right triangle MNC over side Q over side QP of the big right triangle QPC repeat again, we derive that side MN of the right small triangle MNC over side QP of the right big triangle QPC is equal to side QM of the small side MC of the small right triangle MNC over side QC of the big right triangle QPC. Because again, we have the side MC of the small right triangle MNC over side QC of the big right triangle QPC is equal to side MN of the small right triangle MNC over side QP of the big right triangle QPC. MC is A over QC. QC is A plus 8, it is 2A, and it is equals to MN. MN is the missing side, so we leave it as it is, over QP. QP is not the side that is given us, so actually we derive that side NC of the small right triangle NMC over side QP of the big right triangle QPC is equal to side MC of the small right triangle NMC over side QC of the big triangle QPC. NC is the missing side, so we leave it as it is. Over QP equals to 4, and it is equals to MC, that is A, over QC, that is 2A. So today we found out that A over 2A equals to NC over 4. We have A the numerator and A the denominator, so A will get cancelled. So in this side of the equation we have to leave with 1 half. 1 half equals to NC over 4. Here we multiply this equation by 4 and finally we found out that NC equals to 4 over 2, that is 2. So NC equals to 2 units in its length. This is the missing line segment NC, that equals to 2 units in its length. NP equals to PC minus NC. Again, NP equals to PC minus NC. So NP equals to PC, that is 4 minus NC, that is 2. So in total, NP equals to 4 minus 2, that is 2. In the next step, I copied the big triangle A and B in an Olympiad and analyze this big triangle A and B. This is the big triangle A and B that I copied from the original drawing. 60 degrees plus 60 degrees, it is 120 degrees, and therefore this vertex again must be equal to 60 degrees in its size. According to the rule that the sum of the angles in a triangle is equal to 180 degrees. So if you found out that triangle A and B is in the equilateral triangle because all of its angles are equal to each other, so therefore AB equals to BN equals to AN equals to 5. From point A, we do perpendicular on CB again. From point A, we do perpendicular on CB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. What is the length of the missing side CB? CB equals to NB minus NC. So CB equals to NB minus NC. So CB equals to NB, that is 5, minus NC, that is 2. 5 minus 2 is 3. So CB equals to 3 units in its length. In the next step, I'll calculate the right triangle AOB in a new page in order to find out the value of AO. This is the right triangle AOB that is according to the original drawing. This triangle AOB, sine of 60 degrees, equals to AO over AB. AO is edge, AB is 5, so in total sine of 60 degrees equals to edge over 5. Sine of 60 degrees is 30 square root of 3 over 2. So square root of 3 over 2 is equals to edge over 5. Here we multiply this equation by 5 and finally found out that edge equals to 5 times square root of 3 over 2. So the right edge equals to 5 times square root of 3 over 2. Our task is to find out the area of this main triangle, triangle ABC. We know that the area of any triangle equals to the base of the triangle times the height to the base over 2. And again, the area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of the main triangle ABC must be equal to the base of the main triangle ABC, that is CB, times the height. The height is AO over 2. CB is 3, AO is edge, right edge over 2. So the area of triangle ABC in total must be equal to CB, that is 3, times the height edge, that is 5 times square root of 3 over 2, divided by 2. So in total the area of triangle ABC must be equal to 5 times 3, that is 15. So in total the numerator we have 15 times square root of 3, divided by 2 times 2, that is 4. So in total we found out that the area that we are looking for in this question, that is the area of this great triangle ABC, is equals to either 15 times square root of 3 over 4 square units in its size. In terms of numbers, the area of this great triangle ABC is equals to 6.5 square units in its size. So we finish with the first question. In the next step I present to you how we solve the second question of this lecture. In the second question, our task is to find out the length of this line segment AP is equals to x. We have to find out the value of x. In the drawing you have a semicircle called QS equals to 16 units in its length. Line segment QP equals to 21 units in its length. We also know that OP equals to 10 units in its length. This is angle PQS, that is a right angle. Again, our task is to find out the length of this line segment AP is equals to x. We have to find out the value of x. So in the first step, we completed the semicircle to a circle, and we extended line segment QP until it touches the circle at this point. We define the touching point of the extended line segment QP with the circle. This point is point M. By doing this construction, we can do peripheral angle SQM. Peripheral angle SQM subtend on SM, and peripheral angle SQM is a right angle. According to rule 5, any peripheral angle that is equal to 90 degrees in size must subtend on the diameter of the circle. Peripheral angle SQM is equal to 90 degrees in size. Peripheral angle SQM subtend on SM. Therefore, therefore SM is the diameter of the circle according to rule 5. Okay, so SM is the diameter of the circle. From the center O, we do perpendicular on QP. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and QP. This point is point N. Actually, by doing this construction, we created here the right small triangle OMN, and we also have the right big triangle MQS. This is angle M, that is a common angle that belongs to both triangles. So in the big right triangle QMS, we define this angle as alpha. So alpha plus 90 degrees plus this missing angle must be, in total, they must be equal to 180 degrees according to the rule that says that the sum of the angles in any triangle is equal to 180 degrees. Therefore, this first missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, in the small right triangle O and M, this is angle alpha, this is a right angle, so this missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. It's very easy to see that the big right triangle QMS is similar to the small right triangle NOM. So why those two right triangles are similar to each other? First of all, this is angle M, that is a common angle that belongs to both triangles. So we can write down that angle M equals to itself is a common angle that belongs to both triangles. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So if you prove that all the variables of the big right triangle QSM are corresponding equal to all the variables of the small right triangle NOM, and therefore those two right triangles can write similar to each other according to angle similarity rule. Okay, again, if you found out that the big right triangle QSM is similar, this is the sign of similar to the small right triangle NOM according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side ON of the small right triangle ONQ over side QS of the big right triangle QSM is equal to side OM of the small right triangle OMN over side SM of the big right triangle QSM. And again, we derive that NO over QS equals to OM over SM. ON is the missing side, so we leave it as it is, over SQ. SQ is 16. This equals to OM. OM is R, it is the radius of the circle, over SM. SM is the diameter of the semicircle, that is 2R. We have R in the numerator and R in the denominator, so R will get cancelled. So in this side of the equation, we left only with 1/2. So 1/2 equals to ON over 16. If we multiply this equation by 16, we find out that ON equals to 16 over 2, this is 8. Again, ON equals to 16 over 2, this is 8. So this is the missing side ON, is equals to 8 units in its length. In the next step, I'll copy the small right triangle O and P in Olympiad and implement the Pythagorean theorem on this small right triangle O and P. So actually, this is the small right triangle O and P that I copied from the original drawing. According to the Pythagorean theorem, in this small right triangle O and P, OP squared, that is the square of the hypotenuse, equals to ON squared plus PN squared. And again, OP squared equals to ON squared plus PN squared. OP is 10, therefore OP squared is 10 squared, that is 100, and it is equals to ON squared. ON is 8, therefore ON squared is 8 squared, that is 64, plus PN squared. PN is the missing side, so we leave it as it is. So in total, we actually found out that 100 equals to 64 plus NP squared. Here we subtract the 64 from the equation, and we found out that Pn squared equals to 100 minus 64 is 36. So Pn squared equals to 36. We will do all of this equation. Find 100 np equals to the square root of 36, that is 6. Okay, this is the missing sign np, that equals to 16 units in its length. What is the length of the missing sign, missing line 7 qn? Qn equals to qp minus np. Again, Qn equals to qp minus np. So Qn equals to qp, that is 21, minus np, that is 6. So in total, Qn equals to 21 minus 6, that is 15. This is the missing sign Qn, that equals to 15 units in its length. In the next step, join points O and Q together by side line. OQ is the radius of the circle. So I copy this right triangle QON in an equation implemented on this right triangle QON, the Pythagoras theorem. Okay. This is the right triangle QON, that the point to the original drawing. This right triangle QON, QO squared, that is the square of the opposite, equals to QN squared plus NO squared. QO is the missing side, so we have to see, so it is QO squared, it is equals to QN squared. QN is 15, therefore QN squared is 15 squared, that is 225, plus NQ squared. NQ is 8, therefore NQ squared is 8 squared, that is 64. So in total, we should found out that QO squared equals to 225 plus 64. 225 plus 64 is 289. So if we found out that QO squared equals to 289, here we took out of this equation. If I found out that QO equals to the square root of 289, that is 17. So if you found out that the radius of this circle is equals to 15 units in its length. AO is also the radius, and AO equals to x plus 10. Again, the radius AO equals to AP plus BO. That is to say, AO equals to x plus 10. The radius AO equals to 17 units in its length, so we substitute AO by 17. So 17 equals to x plus 10. Here we subtract 10 from this equation. If I found out that x, the 97 that we are looking for in this question, it is equals to 17 minus 10, it is 7. So if you found out that the length of this 978 feet is equals to x, is equal to 7 units in its length. Okay, thank you very much.